Hey, this is Math Minutes Pro with Dr. Harrison. Today we will talk about how to use properties of exponents to simplify expressions. Now first I'd like to examine parts of power just to build our vocabulary because we're going to be using some terms throughout this lesson. So let's begin with something x raised to the y power. Okay? So this x value right here, we're going to say that is our base. And this y, we'll call that the exponent. Okay? And then x to the y, the whole entire thing, we'll just call that the power. Okay? That's the power. Very good. So, what I'm first going to start and do is to list the various properties of exponents and give examples, and then we'll get into a very comprehensive problem where we can apply these rules or properties to simplify a rather complicated expression. So let's start. When we have x raised to the a power times x to the b power, in this case, we are multiplying powers with the same base. When you multiply powers with the same base, what you do is you keep the base and you add the exponents, a plus b. Now, if we have a power raised to a power, let's say ax to the a, and then we raise that to the b, in this case, we have a power raised to a power. What you do is you keep the base and then you multiply the exponents. Very good. Now, if you have a power where you have a negative exponent, that is never simplified. That is equal to 1 over x to the a, but notice we dropped the negative in that exponent. All right, now, what if we have a case where we are dividing powers with the same base? So this is x to the a divided by x to the b. When you're dividing powers with the same base, you keep the base and subtract. Take the top exponent minus the bottom exponent. Very good. Then there's one where we have a rational expression. Let's say we have x to the a divided by x to the b. And in that case, all of this is raised to, I don't know, let's say to the v power. How about that? Now notice we really have in the numerator a power raised to a power and a power raised to a power. So right, you guessed it. What that means is we're going to take that power, we're going to take that base in the numerator, and then multiply the exponents. So that's a times v, and do the same thing in the numerator. That's x to the b times v. Now, let's look at some examples of these properties. When we are multiplying powers with the same base, it says we keep the base and add the exponents. So if I have x to the second power times x to the third power, we're going to keep the base and add the exponents. So that 2 plus 3 becomes 5. Here, in this case, when we have a power raised to a power, if, let's say, we have x to the second power And let's raise that to the third power. In this case, we're going to keep the base, but this time we're going to multiply the exponent. So that 2 times 3 is going to give us 6. I've seen students mix these two properties up, so be very careful with that. Here, let's say we have x to the negative 4. All right, remember, an exponential expression is never simplified if we have a negative exponent. So that's going to be equal to 1 over x to the 4th. Drop the negative. All right, let's say we have, now in this case, we're going to be dividing powers with the same base. We have x to the 5th power divided by x to the 2nd power. In that case, that's going to be x to the 5 minus 2, subtracting, giving us a final of x to the 3rd power. Now we have this one where we have a rational expression. So I'll make up something, let's say x to the 2nd power divided by x, I don't know, to the 3rd power. And we'll put all of that, let's say, to the 4th power. Now remember, looking at this rule or property over here, in the numerator, we keep the base, and we have a power raised to a power we multiply. So we multiply these exponents, we get x to the 8th power. And then same thing over here, we have x, and that's going to be multiplying 3 and 4, which is going to give us 12. So this is great. We've been able to look at the algebraic aspect of using properties to simplify exponential expressions, and then we have some examples. Now we are ready to look at how we can apply these properties all at the same time. So I will start with an expression. Let's see, we have 2 times y to the 3rd power times 3 times x times y to the 3rd power. And we're going to divide all of that by 3 times x to the 2nd power times y to the 4th power. I always like to double check and make sure I'm writing the numbers correctly, because if you write the numbers correctly, but if you do it, if you write them incorrectly, but if you do it right, it's still going to be wrong. So I'm just double checking. I get all my numbers right. It looks good. 3 times x squared times y to the 4th. All right, everything looks great. Now, I always look and see where we have coefficients, which is the number in front of the variable. I always look to see if I can cross out a coefficient. And I notice that I can, in this case, I can cross the 3's out here and here. So that's great. That simplifies things a little bit. So first thing we're going to do is we're going to use the property of, let's see, we're going to put the y variables together, which is the commutative property of multiplication. So we have 2 times y to the 3rd power times y to the 3rd power. That's that right there, times x. Very good. We took care of everything in the numerator. Now, let's go ahead. There's nothing much to do in the denominator. We're just going to bring down the x squared times y to the 4th. So look in the numerator and see if there is a property that applies. I see that we're multiplying two powers with the same base of y, so that means we can keep the base and add the exponents. So we're going to do that. Running out of space, so I'm going to come up here. Very good. So I'm going to write 2 times y. We're going to keep the base and add the exponents, so that's 3 plus 3 times x. And don't forget to write what's in the denominator. That is, there we have, I'm going to bring the y, make the y first to the 4th, and then x squared, okay? Now, I can put that dot there to imply multiplication. I don't have to, but I will. All right. So let's simplify again. There's nothing to do. Keep the 2, the coefficient, and that becomes y to the 6 times x. Then we have our y to the 4th, and then we have x to the 2nd power. All right, we're almost there. Now, I see that in this case, we're dividing powers with the same base for both the y and the x. Here, let's see if we can find that property. Yes, it's right there. When you're dividing powers with the same base, keep the base and subtract the exponent in the numerator minus the exponent in the denominator. So we're going to do that. So we have 2 times y to the 6 minus 4. That's what we did. And then times x. Now you can't see an exponent here, but it's really a 1. Okay, that's right there. So that's going to be 1 minus 2. All right, it's assumed to be 1. Just like in this variable, the coefficient is assumed to be 1. All right, we're almost there. So then, simplify it again. We have 2 times y to the 2nd power. And then we have times x to the -1. Now, we're almost there. But notice this exponential expression is not simplified whenever you have a negative exponent. So we need to rewrite this without having the negative exponent. Can you find that property? It's not this one. It's not that one either. There it is. We have a power with a negative exponent. You write it as 1 over the power and you drop the negative. So we're going to do that over here. So that simplifies to 2 times y to the 2nd, and that's going to be times 1 over x. All right, to the -1. I don't have to put the 1 there. Now, there's one more step. We're just going to multiply. All right, you can, this is the same as multiplying fractions. You can put this over 1. And then our final answer, 2 times y to the 2nd times 1 becomes 2 times y to the 2nd. Very good. 1 times x becomes x. This is our final answer. 2 times y to the 2nd divided by x. Very good. So I noticed that I think we used about 3 different properties in one problem. This was the original problem, and it's simplified here. So thank you for watching. If you found this video helpful, remember to like, comment, and subscribe. Don't forget to check out my Patreon page in my video description below. On my Patreon page, you can get access to exclusive math lessons, study tips, live Q&A, and more. See you next time.